Good morning, everybody. I am Anusha, working as assistant professor in computer science department in the Institute of Aeronautical Engineering. Today, we will be discussing about thread priorities, join, what is the use of join method and is alive, and how we can interrupt threads. In the previous video, we have discussed about how to create threads in Java. There were two ways in which we can create threads. One was by making use of runnable interface, and the other was by extending the thread class. So by these two methods, we can create threads in Java, and we can also create multiple threads at a time, so that as a big job can be divided into smaller jobs and given to each small threads, so that all the work can be completed parallelly. We can assign priorities to all the threads. This priority will determine how these threads will be treated when there is a group of threads, how these threads will be treated among themselves. Like which one should be executed first, which one should be executed next. That order of execution can be determined by the use of priorities. So whenever if we have some in Java, there are the priorities goes from 1 to 10. So the thread with lowest priority may be 1 and thread with highest priority is 10. So if there are threads like say with priorities 1, 3 and 5 executing, then 5 is the highest priority thread. So if there are 3 threads executing and they are of different priorities, then the threads with the highest priority will be always given importance to execute the program, or will be given the CPU to execute its work. Now, there can be threads can switch among themselves. Like it may go to sleep and it may jump to other thread. The control may be given to another thread, the CPU may be given to another thread. So this switching between threads is called as context switch. The switching of threads between among themselves is called as context switch. So the thread priority is used to decide which thread has to give up their control. So there are different ways by which the threads may give up their control. So it may voluntarily relinquish its control when it goes into sleep mode for any IO operation. So if any IO operations are going to work, then that thread may put to sleep until that IO operation completes. So when a particular thread goes into sleep mode, or when it relinquishes its control, the other threads will be checked for the priority. So the highest priority thread among them will be given the CPU, so that thread can complete its work. Now, that is one case in which the thread context switching happens. Another case is that we have a lower priority thread executing, and in between a higher priority thread also comes to execution. So what happens that the higher priority thread will preempt or will stop the lower priority thread from execution. That means the control from the CPU may be taken away from the lower one, and it may be given to the higher one. So this is called as preemptive multitasking. So wherein the higher priority thread may preempt the lower priority thread. So it will stop the lower one will stop its execution, and the CPU will be given to the higher one. Now, if there are threads with the same priority, among all the threads are with the same priority, then it follows a round robin fashion, wherein one thread will be assigned some time slice. So, or every thread will be given some particular time slice, and that thread will execute until that time. Say for example, it will be given 1 millisecond time or 5 millisecond time to execute its work. Then after that particular time, the next thread will be given the CPU, so that every thread will get enough time to work on it. Now, in Java, there are the priorities range from 10 to 1. The 10 is the one which maximum priority, and 1 is the one with 1 is minimum priority. And by default, the threads will take up the value 5. The threads are of size, the priority is of size of value 5. So basically, the main method priority is always the normal priority. So its priority will be always 5. We can use the method set priority to assign some to set a thread's priority. So we can assign any values ranging from 10 to 1. It can be any values ranging from 10 to 1, and these are static and final variables within the thread. These priorities are defined as static and final variables. So we can set the priority by making use of the set priority method, and this is the syntax for it: public final void set priority, and each level, the level indicates the priority value. To get priority of the currently executing thread, we make use of the method get priority. So when we call get priority on any executing thread, it will return the thread's priority. Now let's look into an example of setting priority and getting any thread's priority. So here we have we are creating a thread by extending the thread class, and we are defining our run method. So inside the run method, we are simply displaying the displaying the name and priority of that particular thread. So inside the main method, we are creating 5 threads. We are creating 5 threads: thread 1, 2, 0, 3, and 4. So these are the threads with the 5 threads which we are creating inside it. Now, inside this we have so here we are creating the object of thread 1, and T1 is set to minimum priority. T1's value is set to minimum priority. T2 is set to normal priority. So minimum priority means this T1's value will be set to, the priority will be set to 1. Then T2 will be set to 2. The normal priority is value 5. T2 is set to value 5. Priority of the second thread is set to value 5. Then thread T0 is set to maximum priority. So we'll get its value as 10. And we are setting the name of those threads to those threads. So here T0 is set to the same thing. Similarly, for T3 we are T3 we are setting as priority 7, and for T4 we are setting it as priority 3. Now we are starting the execution of all these threads. So what happens here is that T1's value was the least, was 1. So it will start executing. Now also which thread to start execution, the order of execution also will be determined by the operating system. The operating system will have so many scheduling algorithm. Based on that only the threads will start executing. But here we have set the priority. So T1 was set to 1, T2 was set to 5, T0 was 10, T4 is 3, and T3 is 7. So these are the priority values. So what happens here is that when we started the execution of all these threads. So T1 started executing. So, but in fraction of seconds, all these threads are starting, right? So when all these threads are starting, we will see in the output as the thread with the highest priority getting executed first. So we are getting the thread with highest priority executing first. It is given the CPU first, and 7, then the 7, the T3 is given because that is the next highest after 7. Then, so we can see the order of execution here. So this is how priority decides which thread to be executed. So for setting the, so inside our, once we create that thread, that current thread is displaying the statements priority of thread, and it is displaying the name and priority. That is why we are getting T0 as the name and 10 as its whichever 10 as the priority. So whichever thread is executing, that thread's priority will be displayed in the statement. So this is how we can assign and assign priorities to the threads, and we can retrieve the priorities of any thread. So we use set priority method to assign some priority to the threads, and we make use of get priority method to retrieve the priority of any thread. So it is this priority which will determine which thread has to be executed first. So which thread has more importance than the others. Next is the use of is alive and join. So if we want to determine whether any thread is executing, whether it is alive or not, we make use of the method is alive. And join method is used for synchronization, can be used for synchronization among the threads. So we make use of the is alive method to check whether the currently executing thread or any thread is alive or not. If the thread will be alive if it has started and it has not yet completed the execution. So we will get the return value will be true in case that thread is alive. That means it has to start its execution, and if it has not started the execution and completed its execution, then it will be returning false. So next is the join method. So join method is we make use of the join method to make other threads wait until the currently executing thread is, let's say we are having the thread, we are having T1, T2, T1, T2 as threads which is executing. So all these three threads will be taking the CPU in random fashion, like it will be determined by the operating system. So if we want any thread, like let's say we want the thread to complete first, and then only we need the thread T1 and T2 to start. So if we, in such scenarios, we call the join method over T, so that T1 and T2 will wait until T completes its work. So we make use of the join method which to allow one thread to wait for the completion of another. So if we have T is the thread object whose thread is currently executing, then T dot join will cause the current thread to pause its execution until T terminates, until T completes. So if we call T dot join and we have all these three executing, then if we call T dot join, then T1 and T2 will wait until T is completed. Now this join method we can specify the time limit until which these threads has to wait by these different variants of join. So if we make use of this join method, then we are not specifying any time limit for that. So for this join method, the other threads will wait for this thread to die. So if we call T dot join, then T1 and T3, T1 and the other threads other than T will wait until T1 dies. Okay. Then we have join method specifying some milliseconds. So it is we specify some milliseconds for the threads to wait. So this T1 and T2 will wait for the specified time to execute. So they will wait for this much time for T to complete. So once this time is over, they may take up the CPU. And a timeout of 0 means it will wait for ever. Now similarly, we can specify the milliseconds and nanoseconds also to apply on join method. So it will wait for that much time. If we say 3 and 2, so it will wait for 3.2 milliseconds until nanoseconds for the thread to die. So let's look into an example. So in this case, we are creating a thread named as thread joining method by extending that thread, and inside our run method we are making use of a for loop, and it will print the name of that executing thread five times. Like it will start from 1 to 5. So we are printing the name of that thread five times. And also we are having the sleep method. So let's say we are having 3 threads. So when one thread goes to sleep, the other will start executing. The other thread will start executing. So what happens if we don't make use of joiners? The output will come in an interleaved manner. So that order is determined by the operating system. Okay. So inside our thread, we are simply displaying the name for 5 times. Name of that currently executing thread for 5 times. Now we are creating 3 threads, T0, 1, TH0, 1 and 2, but we are not setting any name for it. So since we are not setting any name, the operating system or the JDK itself will assign the name. So this is how the thread name will be assigned if we are not manually assigning it. So these names are assigned by the JDK itself. So we are creating 3 threads. Then we are calling the start on TH0. Now, so what happens now? We are since TH0 has started, if you call is alive on TH0, then that thread will return true since it started its execution. Here we have created a thread, but we didn't call the start method on TH2. So that TH2 has not started its execution, so it will not be alive. So at this point, TH2 will return false. So we are getting inside this, it is checking where we are creating 3 threads. We have created 3 threads, and at this point we are only starting the TH0. We are starting TH0. So what happens when TH0 is started? Since TH0 has started, it will return true. So that is why we get the value true here. Now in the other case, we created the thread, but we didn't call the start method on TH2, and so when we check the is alive, we will get false for that TH2. Now we are calling TH0 we are calling join on TH0. So what happens? All the other threads will have to wait until this thread completes. Now so this TH0 started execution. Now if then we are starting TH1 and 2. Now if we haven't called join on this method, these outputs, we'll get all these outputs in an interleaved manner. So it may be 1 2 0 1 2, then again 1 2 0, any order. It may be executing in any order if we didn't call join. But since we have called join, only after the completion of TH0 is the TH1 and 2 starting. So that is why we get all the TH0 is being TH0 is the thread 0 is completing its execution, after which we are starting the other 2 threads. So let's see the execution of the program here. I'll just show you here. So if we start executing, right now in this case, I have commented the join statement. So all these 3 threads, the TH0, 1 and 2 will start executing. So what happens there? Let's see the output. See, we are getting all these things in an interleaved fashion. So initially when we started, we got that as true. the th0 as true, and then we got thread 2 also as thread 2 didn't start execute, was not started at that point, so we got it as false. Since we didn't now here we didn't call the join method, so see here we are getting it is in an interleaved manner. The order, and that order will depend upon the operating system. Okay, so this order will depend on the OS, and since we didn't call the join method, we are getting the execution in an interleaved manner. Now, since now let's say we want to stop the we want other threads to wait for the completion of T0. What we do? We are calling join method over it. So when we call join method over it, we can find that only after the completion of only after the completion of this thread is the other thread started its execution. So other thread started the execution only after the completion of the thread 0. So this is the importance of making use of join method in our threads. So when you call any when we are calling we are calling join method on the 0 thread 0. So but we are having thread 1 and other threads also executing. So what happens here? Even though they started, these threads are waiting for the thread 0 to complete. Next is about interrupting a thread. So interruption means we are making that thread to stop what it is doing. So interrupt is when we interrupt any executing thread, it will stop what it was doing and it will start doing something else. So for example, it may be sleeping, so we can interrupt it to start responding to the work. So the programmer will be deciding how this thread should be responding to an interrupt. And there are many methods which we use for interrupting a thread. We can if we invoke thread sends an interrupt by invoking the interrupt method on the thread object. So if there are many methods that throw interrupted exceptions such as sleep that are designed to cancel their current operation and return immediately when an interrupt is received. So whenever we call an interrupt method on the thread, what happens? It will stop what it was doing right now, and it will move on to the next phase. So it may happen when the thread is in sleeping or waiting state, and if we have any thread in sleeping state, then if we call interrupt on that thread, then it will break out of sleeping. It will wake up from the sleeping stage. Now, if the thread is not in sleeping or waiting stage, and then if we call interrupt method, it performs a normal behavior and doesn't interrupt the thread, but sets the interrupt flag to true. But if it is breaking out from the sleeping state, it will throw an interrupted exception. So these are the various methods which are used for calling interrupts. This interrupt method is called when to interrupt in that thread. So to interrupt any thread, we make use of the method interrupt. Then we make use of the static method interrupted to test whether any thread has been interrupted or not. So this will return a Boolean value. It will return either true or false. When we call this method interrupted method, then it will clear the interruption flag. It will check whether that thread is being interrupted, and it will clear the interruption flag. Now there is another method is interrupted, which will again return Boolean value, and that is an instance method. So it will return the status of the thread whether it is interrupted or not, but it will not clear the interruption flag. So these are the three main methods which is used to interrupt any thread. So let's look into an example. So here we are creating a thread named as test interrupting thread, which will extend a thread class. Then inside that we are printing some statement. Then we are putting it to sleep, and within the main method we are calling interrupt. So this once the thread is put into sleep, if it is interrupted, it will be displaying some messages. So here we have the main method. Inside the main method, we are creating an object of the thread and we are starting it. So once that thread started, so we will get, it will print the main statement, and now we are calling is interrupted. So is interrupted, it will check whether the thread is interrupted or not. So in we have our thread 1 started. So when thread 1 has started, when thread 1 starts, it will print the value, that print task. So we get task here. Then just after it's started, it will come back to main. So it will, here it is checking that whether that T1 is interrupted or not. So we are calling interrupted method over T1. Since we didn't call interrupt, we are at this point, we are not, till now we haven't called the interrupt method on T1. So the output will be false. So we are getting the T1 is interrupted as false. We get the value as false. Next we are calling the interrupt on it. So it might be, now by this time this thread must have gone to sleep. So when you call this interrupt interrupt method on that, since it was sleeping, it will throw an interrupted exception. So that is why we are getting this statement. And then after, we are checking whether that thread is interrupted or not. So when that thread is interrupted, you will get this statement. It is executed as true. So it will that thread is being interrupted. So when you call, so at this point, the interrupt was called on the thread, so it will throw an exception, and then it was checking whether that thread has whether this thread has executed or not, or interrupted or not. So since we had called this interrupt method over that thread, an exception will be thrown. So we get that exception, and then it was setting the output as the interrupt flag. It is setting the it will return the value as true since the thread has been interrupted. So in today's video, I have discussed about thread, how to set priorities for the thread, then how to interrupt any thread, and what is the use of is alive and join methods in threads of Java. So to prepare these today's slides, I have made use of the textbook Complete Reference by Herbert Schild, and the tutorial from Java tutorial from Oracle, and the website Java T-Point. So that is all for today's video. Thank you for watching my session. We'll continue in the next video.
Like, share and subscribe. Hit the bell icon for more updates.